I think it's already a bit after 2. So good afternoon to everybody, and I hope everybody had a nice lunch. And this is, I think, the first session for the security, the first talk of the security session. And my name is Elena Reshitova, and I'm coming from Nokia Maemo platform. And I don't know if many of you are familiar with this N900 device. So this is a device which runs open source development platform. The name is Maemo. I guess there is even a competition where you can get some of these devices today. And I'm working for platform security in Maemo, and the new platform security which is coming for Maemo 6 release. And this presentation is supposed to give a short overview about Maemo platform security. And let's see how much time we have. I would like also to leave a time for questions. So here is a short outline. So first of all, I will just briefly talk about what is platform security, or to be sure that we speak the same language when we say this term, platform security. Then we will take a look on two different device modes of operation for Maemo 6 device. And I will say the reasons for these two different modes, and also during the boot we will take a look on a boot process to understand how you can get these two different modes loaded. We will take a look on access control, one of the primary things in security framework, and we will take a look on different things related to access control. Also integrity protection, and we will finish with security of inter-process communications. So what is platform security? So here's in the slide it says that it's a set of mechanisms and techniques which are used to protect the entire software platform. So let's imagine we will try to build a house which is called platform security. So what are the bricks here? So what are the mechanisms and techniques here? So in the bottom of our house there is a big brick called hardware enablers. So this is actually a very important piece for whole platform security. So these hardware enablers are needed in order to guarantee that software, the security software which runs on top of it, it's actually really secured from the software and attacks, possible attacks. Then there is 3 middle bricks, which here stand for integrity protection, access control, and privacy protection. So integrity is we need to protect integrity. In this case, it's integrity of binaries, executables, also configuration data files. So everything which we would like to be sure that it was not modified during the lifetime of a device. Of course, authorized modification are allowed, but on non-authorized or not. And when the access control, very known thing in security frameworks, so who is allowed to access what and why and so on. And a very last one is the privacy protection. So here it mostly means the encryption of user data or your private data for reasons that you would like to keep them secret and not accessible for anything else than a set of, for example, limited programs. And on the side of all these bricks of our house, there is a key management. So key management is needed on all of these levels. So that's why it stands aside. And on the top of the house, there is a roof, it's called here security policy. So this is the control point of whole platform security. So security policy defines how all these mechanisms are working and what is the needed security level. So this is really just a couple of words to explain what is platform security. And so now let's move to the interesting parts. So here a slide called device modes. So many people are afraid, so Maemo platform is an open source development platform. And many people are afraid that now when I'm starting to speak about platform security, it means, okay, the platform will be closed. So when there is like a common understanding when security comes, the platform goes closed. So and that's why I have this first slide already explaining you that it's not going to be the case. And we will take a look on the first mode of device operation. There is no particular name for this mode. I don't know, we probably will come up with interesting names after. But this mode of device operation is the same mode as we used to have on previous Maemo releases. So for example, in this device runs Maemo 5 release. So you can do whenever you want with a device. You can compile, build your own kernel. You can run your own kernel, you can make any low-level platform development. So whenever you were able to do before, you can still do, and there is a special mode even for you to do it. So the only thing that you would need to put your device, Maemo 6 device, to this mode, and then you can do things that you would like to do. There is a second mode, which going to be for Maemo 6, and the reason for introducing this mode, which I would like to have to even extend even more our developer offering. So we know that there are developers who would like to make a bit of profit from their own very good software, and we would like to give a choice to them to do it. So it doesn't mean that when it says here copy protection, it doesn't mean that all software needs to be copy protection and it will be DRM protected. It's just a choice for you. So if you would like to have the possibility to earn money on this platform, you can use the copy protection, you can put your software under DRM. But if you don't want to do it, there's nobody who will force you to do it, so you can still distribute open software, and it's more than welcomed. And there will be also a way to move between these two modes, and this can be done via the booting process, and next slide will show how actually you can reach each of these modes. So the boot process, very high level, so not many details. We'll start from a boot ROM, which will first check integrity of the loader. And if integrity of the loader is okay, the loader can continue. So the loader starts to run, and it will check the integrity of software image. And if its software image is considered to be Nokia signed software image, then this second mode, which I showed on the previous slide, so the mode which provides you DRM protection and like access to application store, which in Nokia called OV store. So you can load this mode because the kernel is fine, the software image is fine, and it's Nokia signed software image. So let's now take a look on what happens when some of these components are not fine. So if the integrity of the loader failed, then we can't allow this because we can't allow untrusted loader, so the device goes to reset, so we're not allowing the change of the loader. But if the integrity of software image failed, so there is still one question to be asked here. So if this device is SIM locked, so SIM locked here means that you, for example, buy the device from operator. Usually it's less price, but you have to use it with the same. I never tried to do it, so you probably have to use it for 1 year with some SIM card, and it's locked to the SIM card. So if the device is SIM locked, then in picture it says that the other image is not allowed, but it's not up to us. So it depends on operator, on your contract with operator, maybe some local legislation in a country. So we really don't have any stand on it. So it's up to operator, but it's also up to you not to buy these devices from the operator. So, but just to mention this part. And then if device is not SIM locked, then we will allow to boot any unsigned kernel, any unsigned software image. There is only one step which will happen in between here with this box saying restrict security functionality. So here, this step we need in order to protect things like, for example, DRM keys, because these keys can't be compromised, and we need to disable these keys. And there are also a couple of small things which happened here. But after these things are done, you can load pretty much any, so you can load any unsigned software image. So the one you did and the one you compiled. So nothing prevents you to do it. So this is, again, high level, the boot process. So let's move to access control part now. And here we got actually quite many questions already that there are many existing access control solutions in whole, let's say in whole operating systems. And the question, obviously, which we were asked is, why are we doing our own access control here? And here's a slide which presents a bit of our reasoning why we decided to go this way. And first, let's start what we had before. So what do the previous Maemo devices have? So the only thing we actually had, it was the classical Unix access control model, which is a very user-centric model. So it was the threat model at that time when it was developed was there was a number of users who were using the same PC, and the goal was to separate data of these users. That one, let's say, some bad user can't read your email, so can't read your private files. So this was a threat model when this classical Unix access control was created. And it was discretionary access control, so user and owner of a file could change the ownership of a file. And later, the situation, we were trying to change this, like let's say extend the classical Unix access control by introducing, for example, POSIX capabilities. And it was, I think, a very good idea, but they're not really in use now. So, for example, root by default has all of them and others users none. So kind of the concept is there, but it's not really used. And then our criteria, so Maemo devices are mostly one user devices, so there's no actually need to protect like one user from another user. So what in the threat model now is that we would like to protect data between the processes, because there's many applications that user installs, and the typical user, it doesn't really understand, and like program may look very nice and things and can be malicious. So users don't understand it, they may install malicious programs, and they may try to steal the data and do other harmful things. So we would like to have the access control, which is in process level. So we don't want to protect users from each other, but we would like to protect processes from each other. And also, important thing that we wanted to have, we didn't want to change the enforcement model, the current Linux enforcement model too much. So the goal was to make a minimal change to it. And of course, things like root level of flexibility, granularity, some concept that would be easy to understand even for a typical user, let's say, not only for specialists. And we did a lot of analysis of current security frameworks and just access control frameworks, and some of them are listed in the slide. And based on this analysis, I don't have time to explain it here, we actually we understood that there was no any of these frameworks which fit our criteria. And that's why we decided to go with our model. And I hope in the next slides I could explain it a bit. There's not much time, but let's try. So if we start from beginning, so what are the principles and key concepts we are using? So the first one is, let's say, a very obvious principle. It's called the principle of least privilege. So we try to, so the principle it says that every application should be able to access only limited set of resources which are needed in order to accomplish its intended task. So not any possible task, intended task. And this is very important in the principle of least privileges. So you don't give more privileges to application which it needs to have in order to make its function. And I think it's a very good principle and basic principle of many access control frameworks and security frameworks in general. And then we have this new concept we called here protected resource. So before on Maemo platform, all resources were available by default. So you call the API to get, let's say, location of the current location of the user, and you get location back. But now some of these resources will be protected. So examples here, like for example, cellular functionality. So the reason to protect these resources is that if the misusage of such resource could cause a harm, first of all, to a user or to a manufacturer of a device, so there is different scenarios. So that's considered to be protected resource. We don't have any final lists. The work is really in progress, so we're not finished with this whole platform security. But we are on building it. We're in the process of building it. And then each of these protected resources will be described with a resource token. So resource token is like abstract name, abstract string describing this resource, and this will be a credential also for a process. So if a process would like to access a protected resource, it needs a corresponding resource token in its credentials. And then our application also, from now, it has to declare the resources it needs. So, and for this one, we will have this aegis manifest file, and I'm going to introduce in more details in the next slide. And also important thing about our security framework, that there is no any security APIs by default, so you don't have to change your application in order to use some special security APIs. You can just use the standard one and benefit from security framework, which is underneath. So a couple of words about aegis manifest file. So in Maemo platform, the software distribution is done inside Debian packages. So, this aegis manifest file is an optional XML file inside a Debian package. So optional means that if you don't need any particular resources, you don't have to put it there. And when this file, as I said, declares needed resources and also provided resources, because our models or our resource token model is dynamic. So any new package that comes, it could introduce a new resource that it personally would like to control and protect. If it has some special, for example, database, its own special database which it would like to protect, it can define a new resource for doing it. So it's not limited in any way with the concept. And then this file should be generated automatically by SDK, given a source code of your program, so that you don't have to figure out actually what kind of resource tokens my program needs in order to function normally. And there is a couple of other stuff about this Aegis manifest file, but I would like to introduce the last concept here. It's called application identifier. So this is the unique identifier of an application and a platform. It's supposed to preserve between, so during whole lifetime of an application on the device, and it constructed in the following way. So it from identifier of software source where this application came from, the package name, and the application name, in case there are many binaries, many applications inside of a package. And we will use this concept a bit later, so it's quite an important one. So still a couple of words about software distribution. So as I said, software comes inside Debian packages, and from a device point of view, from application manager point of view, each package has a software source. So in classical way, when it's based on repository signing, so classical Debian distribution way, it's the source is software repository, or it can be also any virtual entity if we're also going to support package signing. So it also be single developer or web page, or somebody who has a key pair and can sign a package. Also, so as I said, that in order to be recognized, this software source has to have an asymmetric key pair, and public key needs to be known for a device. And a private key used to sign the package is quite standard things. And on the device, each software source is assigned a trust level. And this trust level we will basically mostly use for, let's say, we'll call it update rule. So that you can't, if you have some package that came from a trusted source, very much trusted source, you should not be able to update this package with a source with less trust, because it may be used as an attack against the user, but user sees nice update which is available under through its, for example, application manager, which nice update of some system, very important system functionality which comes from some completely unknown, maybe even malicious source. So this is the way to prevent such an updates. And I will move forward. So Aegis security policy. So as I said in my first slide, that security policy, usually it's a control point of whole platform security. And this is our control point. And by the way, name Aegis doesn't, I know that there is somebody else who is using the same name, so I think it's just collision of names happened. So we don't have anything to do with that Aegis. So Aegis security policy, it contains a mapping between software sources and allowed credentials for that source. So there's an example here below, but there is like 3 software sources there. One is Nokia, now one is Maemo.org, so our open source development portal. And then there is a list of resource tokens which this source can potentially grant for an application. So if an application comes from the source Maemo.org, it can get user data, can get access to user data or cellular functionality if it requires it in its Aegis manifest file. And this policy can be changed for different devices in order to provide different security levels on the devices. So this policy can be very strict or very lightweight, and this is how you can change the security policy. And now let's take a look on installation time, so how the components interacting with each other, and how actually the application at the end gets the runtime credentials. So the application arrives to installer together with Debian package together with Aegis manifest. Installer consults the Aegis security policy to get the allowed set of credentials for that software source, because it can determine the source of this application. And then, based on this Aegis manifest and Aegis security policy entry, it computes a rule, so used what we call intersection rule, which I will show on the next slide, and it computes the runtime credentials of a process and writes it to the file here called credential position list. So let's take a look on this intersection rule. So very easy. So we have address manifest inside a package which declares what kind of application would like to access. So in the example on the right side, where it's user data in Celeron. So application would like to get the access to user data in Celeron functionality. And when it comes from the software source, and the software source declares what kind of credentials this application can get if it arrives, if it was certified by that software source. And an example here, where is user data and location. So, and at the end, the result credential set, result runtime credential set here for the example contains only user data. And this is because that it can't get the Celeron. It requested the Celeron here in address manifest, but it can't get it because the software source, this software source can't grant this resource. It doesn't have enough trust to grant this resource. And it also doesn't get location because it simply didn't request for location. So it didn't say in address manifest that it needs location. And this result credential set is actually the result runtime credential set, which will be added to the process. And here's the runtime. So what happens when an application starts? So at the moment when it starts, we have a component called process credential assigner, which goes to this credential position list. It finds the entry related to this particular application. It finds the credentials, with runtime credentials, which are allowed for this application. And when it loads them to the process task structure in the form of supplementary group IDs. So this is how it's done technically. And when after process start to execute, and it's always have this supplementary groups IDs attached to it, so credentials attached to it. And when the access control happens, for example, for file system, it happens as before. So there's no any changes here. So there is file access control list in the file systems, and there is process credentials, and there is no any changes. In case of dbus inter-process communication, we have a small patch to a dbus daemon, which it's like small addition to dbus daemon. The only thing that addition does, it allows the dbus daemon to take into consideration the supplementary groups IDs, because by default, dbus daemon takes in, when it makes its access control decision, it takes into consideration only user ID and group ID from static files. And when so dbus daemon loads the process credentials and dbus policy, so dbus configuration file, it's called in dbus terminology. And then it can make an access control decision. And there's going to be also a third way for application to make an access control. It can do it by itself. So it can call our libcreds library. So we'll provide a special library to get credentials of another process. And then it could check for special credentials it needs. And then make a decision if we'd like to have this application accessing some API or get some particular data. And just to finish with access control part, I would like to explain shortly this shared libraries case. So what happens when the application tries to load a shared library? So in the example here, we have an application which has two resource tokens in its credentials, seller and user data, and would like to load library A. And we have like a bit of information here that suppose library A comes from very strange source, and this source is not unknown to device security policy, so it's not known, it's unknown source. And what happens? So the application sends a request to kernel to load the library. Kernel redirected to our library checker component, which gets the credentials of application with seller and user data. It will determine the source of a library, and it will load the credential set corresponding to that source. And then it will simply make sure that both sets are matching. And in this case, there is a mismatch because application has access to seller functionality, but the library source can't grant it, so unknown source can't grant it. And in this case, the loading of library fails. And this is needed from security point of view in order to prevent that trusted processes loads very untrusted shared libraries, because after the library is loaded to the process, it's in the process context, so it gets access to the same things that process gets. So very simple rule to avoid these things. And when in case it's a library B, which comes from the source which can grant seller in this example, the loading will succeed and everything is fine. So let's move on to the integrity protection now. So we have two main components here. First one is address validator, So this is a component which ensures the integrity of all executables and all different executables like binaries, libraries, scripts on the platform. So just a small picture how it works. So we have an application binary, which is about to be started. We have ITS validator, which will calculate the hash over this binary. And then it will get the reference hash for this binary from a special storage. And the storage is populated during the installation of the corresponding package which brought this binary in. And it will try to match these hashes. And if everything is fine, so the hashes match, then the binary can start to execute and everything is fine. But if there is a mismatch, the integrity protection policy will be taken into use. And now it's very simple, so currently if there is a mismatch, the binary is simply not allowed to be loaded. Because if the binary was modified on the device and not via software update, so just simply modified, there's probably something wrong with this binary. And then the storage of reference hashes is also needs to be, we need to protect the storage because it's quite an important part of information. And for this, we use the component we call ITS protected storage. It's on the next slide. So this component can be used and is used to ensure the integrity of data and configuration files. So I also get a small example here. So we have an application which has some data or configuration files, and suppose it would like to protect the integrity. Yes?
Can applications also put data on that protected storage?
Yes, so it can be used by applications as well. So I will explain. It's actually simply, it doesn't have any size. It simply add you a signature or encryption over it. So it's just your data. It's not any particular size. Okay. So you just use the services we'll consider it in the picture to encrypt or send the data. So you have this ITS protected storage APIs. It's a library which you can use. So you can call the API of this library to kind of place these files in protected storage if you would like to guarantee integrity. But in principle, it will just sign the data in its own way. And then every time you would like to check if your data is still okay, you can use a different API from the same library, which like check integrity on a high level, and it will get the signature, it will verify the signature, and it will report you the status. So it will say if this integrity of this data is okay or not, and it's up to you what to do afterwards. So you can, even if its integrity was, it's not, if the file was modified, maybe you will decide to use it anyway. But it's just a mechanism that you can use. And also this protected storage provides you not only integrity protection, but also encryption. So it could provide you, so you can use it to store securely the files which you would like to encrypt even. And this even survives the offline attacks. So it's really encryption here. And just to finish, I think I have a couple of minutes left. Let's move to our Ipc communication. So yes, pardon.
So technically it's file on the disk then? That's encrypted?
Yeah, it's simple file. You can open it and you can see what all stuff is encrypted where you can't even. So you can open it in a normal way, but you will see that the content is encrypted. It doesn't make any sense.
But the key will eventually be stored somewhere, right?
The keys are stored in hardware, so you don't have to worry about it.
So which hardware stores the key then?
We have this, but I didn't mention it in the first slide, what we call trusted execution environment. So this is the hardware enablers which we are using.
Like a TPM?
For not mobile word, for PC word, there is a TPM. For mobile word, there is a different technology. But you don't have to worry about it, so you don't have to worry about key management in this case at all.
I was wondering how you protect the file from being tampered with, or how you detect whether the storage has been tampered with.
But if you have a signature, so usually how the signature works, so there is a hash computed and we verify the signature of the file. But you don't have to really kind of call the special IPS to verify the signature. You have only one IP that says, okay, check integrity, and this does all these cryptographic things in behind.
The system itself, and it comes all down to the key security. And if the key is stored in hardware, then the attacker will probably have a hard job to reveal the key.
Yeah, pretty much. So I think this is the last my slide, so let's go over it. So here's another situation. You have an inter-process communication inside a device, and you may be afraid that while you're transferring something, for example, over D-bus, you'd get somebody kind of read the data. So here I have two applications, which application 1 would like to let us some data, it would like to send it to application 2, over this kind of cloud thing we call here potential untrusted zone. For example, it could be D-bus or any other inter-process communication. And then what the application 1 can do, they provide also a library which called Maemo library, which it can ask this, the corresponding API from the library to sign this data in this case, and it will be, the data will be just returned together with signature. And then the data, when the signature can be transferred over, for example, a D-bus or anything else. And then an application 2 can use the same library to check if this data really comes from application 1. And again here, the good thing, you don't have to worry about any key management to establish the keys or to do. Everything is done again in hardware. All the key management is done. And there is very convenient APIs to use to actually check these things. So the same could apply for encryption, so that you can encrypt some data using Maemo API. You can transfer the data over the, again, example, D-bus. And then another application could decrypt this data only if it's possessed some, for example, resource token. The mechanism of resource token is used here as well. So you can say that you can encrypt the data and say everybody who has a user data, access to user data, can decrypt this data. Or everybody who has access to location data can decrypt this data, because I know that inside there is location data. So it's very convenient and it's very flexible. This is how you can also, with the usage of another library, you can secure your Ipc communications. And short conclusions. So our goal is to open source most of our security framework. It's not only up to us, we're coming from a company, but we'll try our best. And then we actually already created a public project which calls Maemo 6 Platform Security, and you can find it in maemotutorials.org. So we already have one repository under there which hosts libcreds library, so you can go check it out and start watching it. We really hope that we will add more repositories very soon. And I can, at the end of the presentation and later, I can answer any questions you have. And the main thing while we're here, because we would really like to get a feedback from you and your opinions about our security framework, because it's the only way to get it better. So we won't get it better if we close and say that nobody knows about it, and we try to make it like very secure. So we don't believe in it. We don't believe in security by obscurity. So we are here, we're talking about it, and we would like to get feedback for it. And thank you for your attention. So if there are questions, yes.
Very basic thing that affects Maemo as we have it now. What happened to the principle of least surprise? I get this device, I want to install something on it, so I apt-get install SSH, and no can do, I need SU for it. So how do I set a password? I can find no information on that, and this is the principle of maximum surprise to a geek, that you can't set you haven't got your own password.
You mean the password for what? For?
Well, so that I can run sudo out of the box. I just need to set a password.
I don't know actually about current devices.
Sorry?
I don't know about current. You mean that when you go to this device, you will not be able to run it as a root, or?
Yes, I mean I have to install a package called extras and get a root shell on it, which means I've got passwordless root and no security.
No, but I think they're going to work on it so that it will be protected.
I mean, to a geek that says I've got no security on here, and
I don't know much about the previous devices. I don't really work even for these kind of devices. So for Maemo, I guess you're speaking about Maemo 5 release.
Yes.
So I can't even say anything about that one. I don't even work for that one. Sorry. Any other questions?
Two questions. You had the access control, said this was based on the software source, so the repository. Is it also more fine-grained? I mean, if I have a repository with thousands of programs, I have a browser that I want to access the internet, I have another tool that I want to access my private data. It's kind of useless to only be able to set it globally for that
But access control is not per repository, so it's really per program on the device.
Okay.
So it's so the repository, the mechanism is a way that so the application on the device has its runtime credentials. So, that, for example, access to some private access to user data, access to location. But there is a control mechanism how it gets. So, for example, if it comes from very untrusted source, some source which there is no reputation whatsoever, and we don't trust this source, then it won't be able to get actually, it can ask for many things inside this manifest file, but it won't be able to get them during runtime. So,
did I misunderstood that source? This means repository, or does it mean something else?
it can mean a repository in a classical way. It can mean also what I said, we are going to support package signing, so it can also mean that it's really per whenever who has a key pair. So.
And the other thing, your example had that the application was talking about the resources that an application can request.
Mm-hmm.
But I guess you also control which resources it can offer, because before you said the program can also offer resources.
No, we actually, so the application the package can provide a new resource. It can't provide some generic resource, so it can overwrite the current resource, but it can provide a own resource. It will be the kind of the space name will be kind of local to package, so that it doesn't conflict with memory resources, but it can provide any resource. There's no actually restrictions on that one. Yes.
When a file is in the protected store mode, does that have a performance impact? Because we have a database that is quite large with a lot of metadata. It's gigabytes in size, and our queries have to be very fast. And yet, our data is probably going to have to be encrypted somewhere along, or at least a large portion of the data. So I wonder about the performance impact. This is a SQLite database, by the way.
So with protected storage, which is going to be encrypted, varies. So it probably should not be used for the database cases, because the database, so we are using hardware for like hardware accelerators to speed up the process. So it's actually quite fast, but for database cases, when you need to access like very often the database, it's probably not the best solution. So we're actually working on one more solution we are working on better solutions, especially for that cases. I hope we can update on this one soon. Yes.
When does the user come into the picture? I mean, all you said was repositories and blah. Is the user ever asked, do you really want to do that?
You're asking about user prompting.
Yes.
So I don't know. I can't really comment on this one in case we'll have it or not yet. So we have to wait a bit. So it's really work in progress now, and the current thing that I'm presenting here is things that we already decided to do.
I have a different question. What about side channel attacks? I mean, you have very trusted processes running in parallel with very untrusted ones on the same device, on the same chip. I mean, if I can measure various things, I might be able to get secret keys out just by measuring. This can happen even over the net.
Yes, so I'm not a hardware person, so I understand what you're talking about with side channel attacks, but I think we have hardware persons who knows about it. And
I'm not talking even about offline attacks where I get a device and I'm trying to take the keys out of the TPM. I'm talking really about the two processes running on the same machine that can monitor each other. And just by that they might be able to find things about themselves.
I understand. The only problem with I'm not a hardware person. I don't know, Jan, if you can comment that one.
Another question, but I cannot say such attacks are generally ignored. There are no solutions to them or get ignored. If you go for certifications, nobody looks at such attacks. They might look at the benefit, so they might try to reduce it, but they're generally completely ignored. Or they just look at the benefit maximum 5K per second or whatever.
Generally, the process separation is trusted.
Okay, I have a question.
Would I be able to still like make the package have the privileges? I mean, if I'm really convinced that the package is not evil, because like it's my own package, would I be able to convince like the package management and the kernel and everything, like as a user?
What do you mean, to install your own package, or?
Yes, with each and every privilege I want.
Okay, we should be very careful about each and every privileges. There will be privileges which you have to actually, in order to get it, you have to be very, very trusted. And I'm not the one, I'm just a technical person, so I don't know to whom these privileges will be given, like, for example, DRM privilege. So this is like very sensitive privilege which I have to protect. But in any cases, for example, I have Maemo.org site, so my version repositories which are going to have quite high trust level, probably. Again, I don't know. I'm not the one who defining these policies. So I'm presenting the framework who actually can do many things, but I'm not the one who will decide, like, but I think on Maemo.org you should be able to do this.
Yeah. So will I be able to, say, modify the list of the trust assigned to each source? Because, like, I mean, it's my device after all, right? So I might want to change, like, the decision not to make.
Yeah, I understand. So if you go to this, when I was presenting these two modes at the beginning, so if you go to this first mode, which when you're allowed to do everything, you're allowed to modify the security policy, you're allowed to create your own, you're allowed to trust, I don't know, maybe your friend repository the most, and when you say that, no, okay, I don't trust, and something like this, but in that mode. Yes?
Canceling that, if he goes to that mode, will my encrypted files be gone from his device?
So if you go between the modes, so the encryption is, so this is one thing we have to.
It has to be encrypted for sure.
So
From a source that doesn't want somebody who is not trusted to look at the data.
so if you had some data encrypted using this, for example, protected storage in this first mode, which was like shipped with DRM things, when you move to open mode, this won't be able to decrypt the data because we don't have any control of the kernel and we can't actually preserve to guarantee anything. So this is just like the thing. But you can still in that mode use the encryption, and then it will be different encryption. The keys are available. Yes.
So these keys are really valuable. How do I back them up?
No. So the key is bound to the device. So you can't back them up because you can't actually transfer them between devices. There is, I know that there is a project in Maemo which is called backup service, which will be able to back up your data, and there is like complicated project or complicated process how it will be done. So you will be able to back up your data, but not the keys.
But then the data is not useful to me, but I have the key, right?
No, but the keys, no, the keys are, no, the data would be probably, I don't know how it will work again, I'm not from there, but it probably will be decrypted and encrypted in some different keys and then pushed to backup, for example.
But then
So,
I have to give Nokia my data, right? Or
No.
trusted third party.
Yeah.
Or trusted
Yeah.
third party, but I have to give away my data.
but it's your choice to use it or not to use it. You don't have to use it in this encryption service.
Yeah.
I feel like I'm 5 years ago or so, because this platform, as it started, as I understand it, and as the question show, is functionally pretty much equivalent to DPM in those aspects for which DPM has been dramatically criticized and rejected by it. So my question is to turn this into some form of constructive question rather than a rant, which I'm otherwise likely to do. Do you expect this to be compatible with version 3 of the GPL, which contains clauses to prevent exactly this type of platform? And there's no concession to any of the discussion that has happened in the community regarding this issue,
So,
which are formulated in the GPL. So do you expect it to be compatible, or do you ignore it?
so Maemo currently is GPL2, and I don't have any, I'm not the one who is even deciding these things, but Maemo currently is GPL2.
And that's why the kernel is GPL2 and will stay that way.
So I think that's a good answer.
Yes.
I'm still on your slide 5, I think. It's the bootloader.
Okay.
Checking if, so,
can try to-
Maemo checks if the file protection.
Hmm?
Maemo checks if the bootloader is from Nokia. I understood.
Yeah.
And I don't know, for me, I'm not familiar with Maemo, but for me, Maemo is like a small PC, and I would be quite upset if a ThinkPad would check if the bootloader is from ThinkPad. And yes, exactly this one.
So, what are you concerned about?
I would like to change the loader.
And
Because maybe I have a OS operating system that this loader is not loading. I want the boot protocol to load another operating system, or
so we'd like to put a different operating system on this
no,
device.
I want to put a different loader because maybe some OS has some needs, for example.
But in this,
This loader maybe doesn't load my OS, and I want to change this loader. And in any PC you can change a loader, but not in a Maemo. And
outside software in particular.
I can launch another loader, no?
Yeah, in the stack.
Yeah, but I want to launch two loaders to load an OS.
But there should be an enforcement point for us. I mean, there should be a point where we actually will make decisions here, and we have to keep at least something.
Yeah, why in all PCs the ThinkPad doesn't enforce the loader, but Nokia needs to enforce the loader.
But if you can get still your own loader, like on top, why do you want to get rid of this loader?
Why not?
That's probably not good reason enough yet. Yeah. Okay. I'm afraid I have to finish for now, but I will be available, and together with my colleague will be available today the whole day for questions. But I think I have to finish now. Thank you.